My next experiment with forces involves friction, and I've got 3 different surfaces here, or 4 if I include my bench, with different amounts of friction. I've got here 3 different pieces of sandpaper with increasingly fine crystals of glass. The smoother the surface, the less the friction should be. So my bench, nice and smooth. My finest sandpaper, nice and smooth because the crystals of glass are really small. As the bits of glass, the grains of glass get bigger, it becomes rougher, and I can feel the difference. More to the point, with an increased friction it should be harder to make an object move. So I've got my object, and I've got my Newton meter, my force meter, and the first thing I've done with my force meter is make sure that it reads 0 when I've got no force that I'm applying to it. And what I find as I pull my block across the different surfaces is that it needs very little force, about 0.3 of a Newton to pull across the smooth surface, and a similar amount, about 0.8, about 0.8 newtons to pull across the smooth surface there. Now notice I'm taking my measurements when the block is moving. There's 2 types of friction. Friction when the object is moving and friction when it is stationary. And what happens, if you think back to that image of friction as being caused by the tiny little holes, the gaps, the bumps in surfaces sort of resting in each other. When the object is stationary, they've settled, and you have to try and pull it out of those in order to get it started. So stationary friction, static friction, is slightly larger than friction when you're in motion. You've also got to make sure that you're pulling your block at a constant speed, because otherwise if you're making it accelerate, you're going to need an extra force there. So this is only about 0.8 newtons when I'm pulling it across at a constant speed. If I try and make it accelerate, it gets bigger. If I move to a slightly rougher piece of sandpaper, it's now about 1.1, and on the roughest sandpaper it's similar, and you can see it's hard to pull it at a regular rate, slightly higher than it was. Now the other experiment that you can do looking at friction is how the friction increases with a heavier object on it. This doesn't mean that we're making the object accelerate. I know we've talked about force, mass, acceleration, things like that. We're moving at a constant speed. But when you've got an extra weight on your surface, it's going to push those dips and bumps close together. So it's going to increase the friction. So what you can do is an experiment where you keep the surfaces the same and you change the weight involved. So if we take our block as it is, we find that the friction, once it starts moving, is about 0.8 newtons. But as we add extra weight, the friction increases. Again, trying for that constant speed. And I'll give you a set of results at the end of this video so that you can see what's going on. Okay, so 2 experiments that tell us 2 things about friction. 1, the rougher the surface, the more friction there will be, the harder it is to pull an object across the surface. 2, the heavier the object, the greater the friction, so the harder it is, the greater the force you need to pull the object across the surface.